Hi, everyone. Welcome to this webinar. As usual, I would deeply appreciate any question and comments that you may have, and feel free to talk to me while we are having this session. I would much rather talk to a real person instead of the rhino on the screen. And the reason we are here today is to answer a very simple question. How do you deploy RavenDB to the edge? RavenDB is obviously a NoSQL document database. It allows you to store data, and most importantly for the current scenario, it gives you a lot of really interesting options with regards to data distribution. One of the primary reasons RavenDB exists is to make your life easier. And one of the big challenges when you start moving beyond a single location, a single data center, is how do you manage the flow of your data across your entire environment? So without further ado, let's see how we are handling this. So the first thing that we need to ask is, what is the edge? And these days, it's mostly about being deployed on site, being deployed not in your own data center, not in the cloud, not in some central location. It means that you have RavenDB running inside of your vehicles. We have users who are putting RavenDB inside of a Raspberry Pi and putting that inside of a truck, or putting a laptop and managing inventory inside of an ocean-going ship, and a whole bunch of other stuff like that. The biggest deployment of RavenDB I'm aware of is point of sale system by a fast food company that deployed us to 36,000 locations. And at last count, there was something like 1.5 million instances of RavenDB, all collaborating to ensure that the system is working properly. Other good example is if you have branches such as the clinics for healthcare providers, laptops that you give to users who are operating on the field, all example of operating on the edge. Now, what makes it the edge versus a laptop? What's the difference? Well, the difference is quite simple. The whole idea is that you may be operating at the edge of the network, but you're still connected, at least you're occasionally connected. So if I'm going to take a notebook and start writing down, pen and paper, that archaic thing that we typically do, then it just stays there. And it is my responsibility at some point to go and update HQ, to update other parties, stuff like that. When we're talking about the edge, we're talking about a system that is at least occasionally connected, or sometimes it is connected except in other certain emergency. So we can assume that the clinic would always have an internet, except when, there has been a pipe bursting or a big accident that took off the internet, but we still need to be able to serve patients. So we have to be able to operate completely independently. A large part of that is this notion of a shared netting architecture. So you can compose your system that there are no external dependencies. So let's see what we're actually talking about here. I'm going to use this wonderful tool. We have a software architecture where we are running on a computer on the field. Now, the field here is a wide definition. It may be on a laptop, it may be on some custom hardware such as Raspberry Pi on the truck. It can be on the point of sale system. But the key issue here is that there is an application and database. Now, there are a lot of ways to try to build occasionally connected systems. And all of them tend to be super complicated. But here is a very simple way of doing that. You have the application talking to local RavenDB node, talking async to the rest of the network. And this sort of behavior, where we have basically made our application completely local, it is only going to talk to RavenDB. It's on the local machine, so it's always going to be up, it's always going to be fast. If there is a network problem, it's still going to be run, and all of those sort of things. And the responsibility of synchronization, of replication, of making sure that everything is working, is at the hand of RavenDB. What does it give you? It gives you a significant benefit in the sense that you don't really have to worry about the network or communication, partial failure, stuff like that. Even if you can assume that you're always fully connected, as in the case of a clinic, or mostly connected, point of sale systems, mostly connected, still being able to talk directly on top of this existing system, on this guy, without having to leave the current environment, means that the latency of your operation is going to be vastly improved, which means that the system responsiveness is far better. So that gives us a lot of benefits, even without considering the notion of partially connected. But it also means that we are exposed to the full complexity of managing this sort of environment. It isn't trivial. So let's talk about the scenario that I have in mind. I wanted to have some fun, so we are going to talk about the Adventure Guild in a fantasy world. The Adventure Guild have offices in many locations. They send heroes to deal with quests, and people can go to a guild house and submit a quest, and heroes can get a quest, perform it, and then submit it. If you have any familiarity with a fantasy, Hobbit, whatever, this should be very familiar. So let's see how this works. Here is our environment. Each one of those locations is a guild house. Here is a guild house. Here is another guild house. And each city may have multiple guild houses. And I can open a quest at any guild house, and I can submit one at any guild house. For example, I may open a quest here, saying this is an SR quest to take me to here. So I would open it here, and it would be closing here. The guild houses now need to share some data. At the same time, quite obviously, I have to deal with dragons. I have to deal with disconnect in the network. So even though I have to be able to create this mesh of setup that I can do everything wherever I want, at the same time, I have to be able to operate completely independently. So how am I going to do that? Let's go and see how this works. So we have this notion of branches, not Git branches, but like physical branches of the guild house. And let's see what we do. Each one of those branches is going to run RavenDB, isolated from one another as a single instance or a cluster or whatever. And then we are going to tie them all together in order to see how this works. So I can keep on talking theory for you for as long as for quite some time, but let's talk about some concrete details. What I have here is a RavenDB instance running in US East under AWS. And I have this one running in South Africa North under Azure. Let's assume that both of those servers, both of those clusters actually, because we have multiple nodes for each of those, is running as a guild house. So let's see what we need to do. So the first thing that I need to do is I need to create the quest database. And now I'm going to have to issue a quest. And kill 10 rats, which is the classic quest you would imagine. Okay. Now, this is a global quest. So now I need to be able to complete it. I need to be able to report it. Notice that right now I'm in New York. And let's say that New York is blue. And now this is Johannesburg, and Johannesburg would be white. This would allow us to very easily distinguish between the different databases, different locations. Now, I have nothing here. No database, nothing. So I have to, first of all, create the relevant database. That's about it. But I have nothing here. Well, obviously I have nothing here because they aren't aware of one another. So what I'm going to need to do now, I'm going to need to create an association between them. Given what I know now, I'm going to go to ongoing task and add an external application. And here we go. And that's it. This would actually fail. Why would this fail? For a very simple reason. There is no trust relationship between these two servers. Let's fix that. So I can go to the cluster and I'm going to the certificates. And I'm going to ask it, give me the server certificate, this guy. On the other side, I'm going to client certificates, and I'm going to say, upload the client certificate. New York cert. And what I've done is now I have the New York cert that would allow me to allow the New York cluster to replicate to the Johannesburg cluster. Now, because I didn't do that previously, then we're currently in a timeout period. Let's go and fix that. I'm going to tell it that the only node for this is node A. And this would move it. This would reset the time of starting this out. And in about a few seconds, we should see some data here. We can actually go here to the ongoing task stats and see what we have. And you can see here is the Johannesburg. And I'm not seeing any details here. This is sad and annoying. Let's see why not. I'm going to go here and ask it, just show me the errors. And we'll wait a bit for this to happen. While this is running, we're going to go here and do the other side. So external application, node A, node B, node C. We have the quest. Again, we have a problem here. Why? We don't trust the certificate. I have to do the other side. Export server certificate. And I will just open another window here. Certificate. Upload a new one. And this is Johannesburg. I'm doing everything in as direct manner as possible to make sure that all of you are able to follow exactly what's going on. Now, let's see what we have here, and let's see what we have here. So this is the risk in doing live demos. Something messed up. I don't know why. So let's see what's going on. If I'm going to go here, let's disable this. And now in here, I'm going to open the admin logs. And now I'm going to trigger this. Start and run. And see a lot of New York. I'm not seeing Johannesburg. Oh, so the problem was, but first of all, we have this guy, Kid and Rats. And the problem was probably about the, there's an name for that, the timeout. We went to a either 1, 3, or 5 minutes timeout for this. Now I want to say level up to 10, let's say, maximum. Now let's do this. And in a few seconds, we're going to see the update here. Now, why did I select these two locations? Why New York and Johannesburg and different cloud providers? Well, the answer is quite simple. Because I want to be able to show the different latency between those operations. So this is this, it will show up. Let's now go to the other way around. I want pick 5 flowers. Now creating the quest in Johannesburg, and it should show up here. The network latency, I have to admit, is significantly higher than I expect. I would actually expect it to be far, far faster. But, you know, it's here. And interesting. Let's check something. Did I save? Oh well. Certainly look like I saved and it's supposed to work. Let's see what's going on. So A2B1C1. And here I have just A1. So it's supposed to be replicating, but it isn't. Next time I would learn not to do. Okay, so this went to B. This is incoming replication from B. Outgoing replication from this, and it didn't find anything. Let's try doing this. 11. And this one, when we look at the replication stats, go replication to A. Here's the other side of that of. It looks like it's unable to connect to us for some reason. I did not close that. Still working. Let's try to move that from another one. But if this doesn't work, then I would stop doing that and I would tell you that I would publish the actual issue for this later, which is probably what I need to do. At any rate, what I was trying to demonstrate, and apparently somewhat unsuccessfully, is that I'm able to actually create a document in Johannesburg and see it show up in New York. And I'm able to do that there. Let's see, quest 3. Pet 3 dogs. You might have noticed a theme in the way that I'm doing that. And it would show up here in a few seconds. It might be that the servers are really, really weak. Anyway, now what happens if I'm unable to connect? And we actually seen that I'm unable to connect. this is a shared netting architecture. We can keep on moving forward without any issue. So that's a major advantage. But now we get to an interesting issue. We are in a shared netting environment, so how do we manage state? How does it work? And let's look at this. We have two styles of quest that we can deal with. The first style is if we have something that is repeatable and easy. What does it mean? For example, kill 10 rats. You can always kill 10 more rats. That's the staple quest in all RPG games. So how do I manage the state of something like that? The answer is that I don't. Here is the next one. The answer is that I don't. Sorry. Submissions. And this is 222. 17. 51. And the quest is something like this. And now I'm doing this. So I have a submission. And I can take the same thing. Oh, by the way, now it's working properly. I created this here, and it show up here. It's now going to do and I don't need any coordination whatsoever. Because this is a repeatable quest. And I create it here, and it would show up here. No big deal. So I said no coordination, but this is wrong. There is one aspect that I have to consider with regard to coordination. What is this aspect? This aspect is the notion that document IDs must be unique in such an environment. What happens if I'm going to try to create the following? Just quests. We're going to generate something like this. And the value there was going to be 1, 2, 3. And now I'm going to generate another quest. This value is not globally coordinated. This is important. So now I have quest number 10. Let's go here and create another quest. This is 11, and this is an accident. But if you go here, you can see that it would show up in a few seconds. I figure out what's going on, actually, by the way. There are 3 levels of latency that we are dealing with here. One of them is from Johannesburg to New York. The other one is from the server to me, and I'm roughly around here. So the stuff is actually happening. We're just not seeing that show up on the user interface quickly enough. Now, what would happen right now, they are sort of coordinated. If I would disable the replication and try to create that, then I would end up with the same document ID for different documents, and that would generate a conflict. So there are 2 ways of handling that. One of them is to just use GUIDs, and GUIDs are guaranteed to be unique, so there's no problem with that. You can either use something like that, or you can use something like this, and generating GUID is trivially cheap, so not a problem. And that would go over the other side very nicely and quickly. Personally, I would much rather do something like this. And I'm not trying to type that. So I would make some unique value in the document ID itself and use that to distinguish between branches and environments. So this is this idea. How do I manage distributed state? How do I replicate between widely separated environments? In the sense that I need to have repeatable values. So it is okay from a business perspective. No, this is not a technical aspect. This is a repeatable quest. Two people can submit it at the same time at the same place. Now, what happens if I have something else? Now we have endgame quest. And this is actually still the crown. Now, this is quite obviously not something that we can actually operate on concurrently. There is one Dreadlich crown. So how do we handle that? How do we manage to avoid two people completing that at the same time? And here we have to go back and understand a little bit about the way that RavenDB works. RavenDB has an obsession. I say RavenDB, I mean me. RavenDB has an obsession with transactions. All operations inside of RavenDB are transactional. But not all transactions are created equal. In this particular scenario, what do we have? We have local node transactions or cluster-wide transactions. And typically, if I'm looking at something like this, I would say, yeah, this can be a local node transaction. And because I need to ensure that only one player can submit this particular unique quest, I have to use a cluster-wide transaction. And this works, except that what happens when I'm no longer talking about a single cluster? When I'm operating on the edge, when I'm operating on something like that, I'm operating on multiple independent clusters. Now, you can use RavenDB in a cross-cluster environment. Sorry, not cross-cluster. You can use RavenDB in a cluster that would spawn all of these nodes. But that would mean that all of the cluster operations would have to cross from New York to Johannesburg. That's kind of expensive. We like all of our nodes in the cluster to be located next to one another. But how do you deal then with this issue? And the answer to that is quite simple. We don't bother to do something overly complicated. This quest has an owner. Submit approval, New York. Now, what does this mean? Think about it. What this means is that if I want to submit this particular quest, what do I have to do? I can only submit it to the New York office. Now, leaving aside the RPG and the game and fantasies, let's talk concretely. Let's talk about an actual example where you will relate to that. Money. I want $50. I go to ATM. I get $50. Really important observation here. It does not matter if I have $50 in my account. The ATM is going to give me $50 based on its own local information. Because the bank would rather give $50 and then try to collect, and they already have the means to collect from people that owe the money, than have me be pissed off at the bank for trying to get my own money from the bank and failing because of some network issue. Right now in Lebanon, there is a woman who is a hero because she went into a bank with a plastic gun and robbed the bank out of $30,000 of her own money that the bank refused to give out. Now, I think that this shows the length of that people would go to get their own money. And there would certainly be a reputation damage to the bank if I asked it for money, and because of some technical problem, I couldn't fill up gas in my car. So this works. But now I want $50 million. Sorry, this bugs me. I go to an ATM. I go to ATM, nothing happens. As it turns out, as long as you're using US dollars and not monopoly money, if you ask the ATM to give you $50 million, he's going to say no. Now, let's assume that you have $50 million in your bank account and you want to move it to somewhere else. Well, I go to a bank branch, any bank branch that of my bank, and I tell them, I want you to move this amount of money. And then the following things will happen. Remember, at that point, we move from a repeatable scenario, $50 transfer, to a unique scenario, $50 million transfer. And at that point, we are going back to this. My home branch, the branch where my money is actually supposedly resides, is the one who has the final approval, yes or no, on big transfers. So what will happen is that the bank would, the local bank that I'm sitting at right now, let's say I'm in Johannesburg, they would go and call the New York branch and ask them to approve this transfer. And something really interesting would happen at this point. What happens if the New York bank is closed? There's a bank holiday, there is out of office hours, whatever. I'm going to be unable to do anything with my own money. But you know what the funny part about this is? For $50 million, I probably would like them to run a few more checks. If we go back to the notion of the Dreadlich request, if I'm trying to submit to New York and I'm unable to do that, in this case, this is a request I wanted to fail. Try again later when New York is online. So this is a distinct scenario between what you're doing. Am I doing something that repeatable should succeed locally and then distributed to the rest of the network? Or am I going to do something that requires me to do this? Do something more interesting, and I have to be globally consistent. By the way, when I'm actually submitting this request, I'm submitting that as a cluster-wide transaction to do New York cluster. So I have one cluster, and inside that cluster, I have a cluster-wide transaction. And we have a question. Thank you, Merdan. Any plans for mobile support? Not related to the topic right now, but I will answer that. So we have plans on being able to run on dedicated Android systems. One of the interesting things that we see from customers is the need and desire to want to run on their own platforms or something like that. And RavenDB already can run on ARM instances, so it's not a big leap from that. If you're talking about mobile as running on consumer phones, that is unlikely at the near future. maybe at the span of 2 or 5 years, but not any nearer than that. So we talked about how we can steal the crown of the dread lich. Now let's see how we can handle another scenario. It's very common in quests that I have the need to do some operation. Now, if I have a guild that needs to do a whole bunch of operations, and they're happening all over the map in environments that are disconnected from one another, how can I complete this sort of quest? The key aspect is that I can do that, but I have to consider exactly how. So let's go and create a guild. And there is a quest. And in order to manage the quest, I have to deal with tracking every time that I forge a sword, every time that I bake a loaf of bread, every time that I'm building a house. And now we're going to see something really interesting. First of all, you can see here. Now I want you to pull up your watches and start timing things. I'm going to create an incremental time series. And I forge a sword. Perfect. It is going to take me some time to see this here. About 5 seconds or so until it replicated from the other side, the Johannesburg notified my browser, it shows up, etc. But here you can see the change. Now let's go and do another entry. And let's go and do another entry. Second. So now I'm going to say 2. And the exact same instance in 2 wildly separate environments, I'm going to hit save. And my goal here is to try to get to the right environment. So I created effective erase condition. That's kind of sad. And now let's go back here and try to understand what's going on. What just happened? I wrote 1 here and I wrote 2 here. And I did that at different times. And we saw the latency between those servers. I explicitly chose them for that latency. But I got the right value. So this feature is part of the, let's do it again. This feature is new in the 5.2 edition. And what it did is basically allow me to do just this operation. Make a write on a globally distributed environment and have everything end up as the right value. You can see that I'm almost there with the number of 4 swords. So this is using incremental time series. If I don't care about the time, I actually have a somewhat lighter weight options and houses built. Houses built. And let's go Apparently we aren't built. I think I didn't. Let's do it this way. Now I want to do 7 here, 6 here. In a few seconds, this one is going to have the actual new value across everything. So you can see that we got the right value. So again, the whole idea is globally distributed, share that environment, and all of that converge into the right value. Now, in order to implement this sort of environment, where I can actually compute when this particular guild crafted all of its requirements, this starts to become really easy and cheap to do so. We have another question from Randall. I understand the concept of the endgame scenario, but I'm not sure how you would implement that. Do you create a temporary document online, and then when you connect, you tell the client to connect directly to New York to update the document? Well, here's the issue. Let's go back here to the map. This is New York. This is Johannesburg. I'm in here, and I'm trying to submit the endgame quest. At this point, I'm submitting the system from here. I'm sitting here, I'm writing this application, and typically I'm only working on this database. But for the endgame quest, I'm going to say, okay, let's read the quest description. The quest description tells me who owns that quest. Therefore, I'm going to go and do this here. The application itself is going to read the document, see where does it belongs to, go and contact the New York office, and do a cluster-wide transaction there to complete this operation. Now, what's going to happen if we fail to do that? If the connection from Johannesburg to New York is down? Well, that's the reason this is a unique scenario. If we cannot report that properly to New York, then we cannot report that. We should now. It is possible that there are scenarios where we couldn't report it to New York, but we record it on our side, or maybe stuff like that. But that would probably mean that you're more at the end of every we are recording. We are basically doing a race. Everyone, I will record this here, I will record this here, and I give it, 2 hours for all of the people to complete, and then I'm seeing who got there first across the entire map. I hope this makes sense, because the scenario is basically tied very closely to the actual business scenario that we're trying to resolve. Okay. So we just finished implementing this quest where we are able to, across the entire map, track everything that happens in the guild without really needing to think about it or worry or any such things. It's just going to make it work. So that's really good for us. Now, there's a problem here. And the problem here is that I don't actually want or trust everyone else in the system. Let's look into that. So now I have another guild. This is a Thieves Guild. As you can imagine, it's not a fun guild to have. And that's interesting. Oh, I'm sorry. What I actually did here, I'm running on really, really crappy machines, this in particular. And that means that there is additional latency going on. So now, I have this quest, whatever. Steal the basket of beer. Type crime. Word. Here we go. Oh yes, sorry. What actually happened is that I'm trying to clone a document that has counters and timestamps, which is not allowed. Let me go and create a new document. Okay. So this is it. Now, I'm going to go here in the certificates. Here's the Johannesburg certificate. And I'm going to add the TIFF skills as well. And basically, I'm having lots of fun here because what I'm going to do is this. I'm going to go to the RavenDB ETL. I'm going to say push the quests to New York because this is, but not, I actually don't want New York. I want, I do want New York, but a different database. TIFF skilled. And now what I'm going to do is something like this. If this dot type is not crime, load to requests. Okay. So what did I just do? And you know what? Let me do something even more fun. Let's go to the TIFF skilled. Not this one. That was here. Didn't I create a quest? I distinctly remember, and this belongs to, sorry about that. So this belongs to the guilds. We just fixed that. Okay. So we can see that it was actually pushed here. I'm going to remove that because this sucks. So still the basket of beer. And let's do it. This is a better one. I think you would have seen. So what just happened? I created two quests. One of them was created in New York, one in Johannesburg. In Johannesburg, I set up an ETL process that would push only the crime quests to the TIFF guilds in New York. And I have to admit that this is me being quite facetious with the way that I'm doing that. But here is still the beer, XX, XX, everything that is needed. Think about what this means. What is the flow that I have for the entire system? I created a quest in Johannesburg and it was moved to the TIFF guilds in New York. I created the crime quest in New York. It was replicated to Johannesburg and then got bounced back to the TIFF guilds in New York. So the notion of data flow and the sort of operation that I have is really strong, and it allows me to do a lot of really interesting things. So let's take this further. We have this notion that we give laptops to adventurers. And leaving aside that they are not gentle with their equipment, we need something that is incredibly cheap, that can operate completely offline, but still can sync that. Now, in the previous example, I had a finite number of guild houses. how is it going to work when I have a lot more of that? How is it going to work when I have thousands of people in the fields that are operating and working and stuff like that? So let's try to see what we can do. I have here, and this is my local instance running on this machine. I'm going to create the hero database. And what I need now is to be able, let's say that I'm running on my laptop, I may be connected, disconnected, whatever, and I need to be able to pull data from the guild, but not all data, just some part of the data. So I'm the hero of New York in this scenario. Now, I want to be able to get the data, but there is a problem. I'm actually listening on localhost. The New York server, the New York clusters, cannot talk to me. That's why we have this notion of a hub and spoke model. So let's look at what we're doing. We're going to go here. We're going to define a replication hub. And we're going to allow it to be both ways and to enable replication. And now, hero New York, this is the particular hero. We're generating a new certificate. That may take some time. And I only want to send the quests and I only want to accept submissions. So what did I just say? I said that replicate from here, from the hub to the sink, from New York to my server, send a quest, from the sink to the hub, from me to New York, send the submissions. Now I'm saving that. Now I can go here. And I actually wonder if this would work because I'm not secured. I have no idea. Let's try. Okay. Now let's see if we have something here that is interesting. So what I basically just did, I used the exported value to push the data from, to push the information. And yes, so this will not work. And the reason it will not work is because I'm running in unsecure mode. You can see that I'm the person who is making the connection, but it still doesn't like it. This is because RavenDB does not like it when you mix secure and unsecure mode. And right now I'm running in localhost. So let's say that I'm here, hero of New York. We're going to define that in this location. Import, save, we're good. Now, what's going to happen now? In a few seconds, we're going to start accepting documents. The documents that we have here only on the quests. We have quite a few of them. They should show up in a few seconds here. Let's do the other side, submissions. Just make sure that I spell that properly. Is the hub. Yes. Okay. Okay. So now, here's what's actually happening behind the scenes. In a few seconds, this is going to be pushed to the other side. 1 second, I did it here. Okay, I did it in the right database. This is going to be pushed to the other side. And the way that the replication works in this case is that we filter the data that we send to the other side. We can do that on a per client basis based on the configuration that you saw. The client authenticated using the certificate. So this guy using this server connects to the remote server, and then we can send him the quests that are relevant to it. And it can push to the server, to the guild house, to the cluster, the information that we want to share on the other side. A key observation that we have to make is that this is supposed to work. Let's see what it is doing. I think that I missed something. Let's see. Now, 1 second. So here is how I diagnose this. First of all, I can see this is running on node C. So let's go to node C. Let's make this white. Here we go. So we expect that to be sent to New York. Here is New York. And this is incoming pool application. And this is going to node B here. Let's go to node B. And again, this should be blue. And see the connection. Here's the New York one. This is the hero of New York coming in. And I think I might have messed up something in the configuration. Let me try doing it other way around. So I created one here. And this wouldn't show up here. Oh well, I'm sorry, live demos is apparently not playing nicely with me today. I'm not sure why. Setting look, hub to sync, quests. And this supposed to be working, I don't know why, and I don't want to spend any more time on that. The key aspect from our perspective is this really interesting question. We can put all of those sort of things together. So with pool application, with what I've just demoed that I unfortunately didn't demo that well, we can have each guild house, each cluster, have its own set of adventures that connect to it and pull the relevant documents. And in here, I would also have a set of adventures that connect to this one. But the whole idea is that I don't need to have a single hub. Each guild house would have its own adventures, that's fine. But the guild houses are also connected to one another, so a write that happened in one location would actually flow all the way to the end. From one server, from one adventure laptop to the guild house they are associated with, and then to all of the other guild houses. And if necessary, you can run it on the and then it can go into all of the adventure laptops as well. So try to imagine that you write it here, and then it flows, and eventually every other machine in the network would have this information. This is fully offline capable, gossip model, etc. Okay. So one last thing that I want to talk about because we are nearing the end of our time, and this is the notion of how do I actually manage global analytics? How do I manage to do those sort of things when I don't have any single central authority? And this is where a feature of RavenDB called OLAP comes into place. So let's talk about a scenario. Every time I complete a quest, I get some money, and the kingdom wants some taxes on that. How does it work? I need to publish that information, but the whole idea is that there is no single location to publish that. For that matter, throwing all of the data from all adventures into a single location may be taxing, pun intended, for the system. I just want to get the data and do processing in the sense of a data lake. So we have this notion of RavenETL, of ETL in general. And one of the options that we have is this one, where we can actually define an ETL process that would push a Parquet file into destinations such as S3 Azure or any of a location that you feel like it. I really like to see if someone is using that, but never mind. I actually do know at least 3 customers who is using that, but FTP for me is so 90s. And then you push those OLAP data to the Parquet file into the OLAP data lake. Now, why does it matter? It matters because the manner in which you're doing that is not through the hub and spoke model. Instead, each individual user would be able to push that data to the data lake. So try to imagine if we're working on a point of sale system and we set this up so every point of sale system would report every 5 minutes about all of its sales. Throwing all of that into some S3 bucket, and then you can use Presto or AWS Athena to run queries and aggregation in near real time over an environment that may have thousands or tens of thousands of edge nodes. What's more interesting from our perspective, because we are throwing all of that into blob storage, S3, something like that, you don't have to pay for the synchronization and the machines and everything to accept and run that. Everything is just thrown into blob storage, which is really cheap, and then you can just run on top of that. I actually have a full webinar on this particular scenario. You can see all sorts of really cool things that you can do there. And I think with regards to my attempts to do this, I'm fairly certain that I messed something up in the configuration. I'm not sure quite what. I'm connected to this one. So New York, this is the Quest database. Wow, look at the time to get this, to get the response. And when I'm getting this, I'm supposed to be, and this is supposed to be working. I'm not sure why it doesn't work this way. Let's see what happens if I do this. I have to do, let's start like this. Now, no, I need here and disable, table. I'm fairly certain this is something stupid, like forgetting the way that we are doing this or something like that. Oh well, I will not spend any of your time about this. I will investigate this later and give you an answer. And now this is the time for questions. So we have Shachar, and he's asking, can we fit a data set from the edge devices so I only send the data that is relevant globally and save on IO? Yes, and there are two ways of doing that. One way is to use the ETL like I've shown, where I've sent only the crime quest to the thief skills. The other way, which for some reason didn't work, is with the filter application, where I can decide based on some prefix here to send it or not to the other side. I've been talking for just over an hour, and I'm trying to cover this really complicated topic of, oh, you have widely distributed environment and you have machines that are coming and going, occasionally connected, a whole bunch of other stuff like that. And when you look into that, this is an incredibly complex system. But at the same time, you saw me set everything up while we were talking. It doesn't require that much effort when this is actually something that RavenDB is in charge of. And you can get those sort of behavior and the implications of that in your own systems. If you have any further questions, anything you'd like to know, feel free to ping me at this email. Thank you very much for showing up for this webinar. Thank you and goodbye.